What do planes and the air they fly in, coal and the trucks that move it, and divers and the water they swim in have in common? They are all made of matter. Matter is the stuff that makes up the universe. It comes in an endless variety of forms and reacts with each other in countless ways. Chemistry is the study of matter.
Welcome to chemistry. This year, we'll be studying matter, its different forms, what it's made of, how it changes, and how it affects our lives. Let's start with the periodic table of elements. By tomorrow, you need to learn all 109 elements in order, the symbol and atomic mass of each, plus one property such as melting point or density, and a use for each. Just kidding, just kidding. I know the study of matter can be intimidating. There is just so much to learn. Chemistry is a branch of science, like biology or earth science. And as a science, it is both a body of knowledge and a method for obtaining that knowledge. This year, we'll use that method to help us make chemistry easier.
During this lesson, you will describe the steps of the scientific method, distinguish between observations and conclusions, and identify qualitative and quantitative observations. Chemicals affect our lives in so many ways, from manufacturing to agriculture to medicine to space exploration. Have you ever wondered how discoveries leading to these products were made? Some were made by accident, but most were the result of careful research, using a logical approach to solving a problem. The way scientists carry out experiments is called the scientific method.
Different textbooks use different terms to describe the steps of the scientific method. So if you looked in another textbook, the terms might be different, but the ideas would be the same. Okay, whenever you hear that sound and see this symbol, it's time to take notes. You'll probably find this kind of information on upcoming tests.
The scientific method is a logical method of problem solving. Here are the steps of the scientific method. We will discuss each step later. Number 1, making observations that lead to a question. Number 2, forming a hypothesis to answer the question. 3, testing the hypothesis by experiments. And 4, making a conclusion based on the results of the experiment.
Today, we will follow the steps of the scientific method to investigate something that every chemistry student wants to study.
When do we get to burn things?
Are we gonna blow something up?
I want to make a really loud explosion.
So, you want to see fire, do you?
Fire has fascinated people since the cavemen discovered how to make and use it. Most of us know what it takes to start a fire and keep it burning. In fact, you probably think you know all you need to know about fire and burning. But in chemistry, we learn to ask questions about what we observe. For instance, why does burning rocket fuel produce a flame that is so much hotter and produces so much more energy than burning wood or propane or even gasoline? What do you really know about a simple flame? Is one part hotter than another? What affects the color of the flame? And where does the stuff that burns go?
What do you really know about things that burn? When chemists want to know more about matter, they follow the scientific method to find out. The first step is observing.
Observing involves the use of the senses and devices in the lab to obtain information.
Now, to help you remember your senses, let's use them to make some observations. But remember that this is chemistry, where safety is very important. Be sure to take precautions at all times. First of all, protect your eyes in case a chemical splashes or spills. Always wear goggles or safety glasses unless otherwise instructed. Never taste anything unless you are told to do so by your instructor. And when you smell a chemical, don't stick it right under your nose and take a big whiff. Ooh, you might knock yourself out and find yourself lying on the floor. Use your head and save your nose. If you've got to sniff anything, keep your nose at a safe distance and wave the fumes towards you like this. Now, with safety in mind, let's practice some observations. Since we're interested in things that burn, we'll start with a simple candle. In a minute, your local instructor will turn off this tape and give each of you goggles to wear, a candle, something to hold the candle, a ruler, and matches. You'll need a piece of paper to record your observations. Start with the unlit candle and make as many observations as possible in the 4 minutes. Then, put on your goggles, light the candle, and observe as many things as you can about the flame itself and about the candle as it burns and after the flame is extinguished. You'll have 4 minutes for that too. Now, don't write down phrases like, "The candle is not red." You could make negative observations forever. Write down what you do see, because no observation is too simple or too obvious to include. You should be able to make at least 15 to 20 observations in the given 8 minutes. How many observations did you get? Let's hear from some of our students about their observations. As you listen, check your observations against theirs. But don't feel bad if you didn't get as many as they do. I helped them out a little. Remember, local instructors, pause this tape if your students need more time to discuss their observations.
My observations are obvious. The candle is white and a little shiny, and the wick is also white, but it's dull instead of shiny.
Let's see, it's shaped like a cylinder, and the top is tapered when it's new.
This candle has a diameter of 1.5 centimeters and a length of 9 centimeters.
This candle is made of wax.
Whoa! I was waiting to hear that statement to point something out to you. How many of you said that the candle is made of wax? That happens to be a correct statement, but it is not an observation. It's a conclusion. There's a big difference.
Remember that an observation is information obtained by using the senses along with devices in the lab. A conclusion is a statement based on observations and prior knowledge. Sometimes this judgment is called inference. Inferences, judgments, and conclusions are basically the same. When you observed that the candle material looked like wax, smelled like wax, tasted like wax, and behaved like wax, and you remembered that candles are usually made of wax, you made the conclusion that the candle is made of wax.
The conclusion might be correct, but then again, it might not be. For instance, would I do this if the candle were made of wax? Gotcha.
Let's listen to our students make their observations, but this time, some of their statements will include conclusions as well. See if you can pick out their conclusions. At the end of this segment, we'll go back to identify the conclusions.
Okay, the candle material smells, looks, and tastes like wax. That's 3 observations without a single conclusion.
The candle material is soft enough to be scratched by a fingernail, and the wick is made of 3 strands woven together.
The wick goes all the way through the center of the candle, and the wick is made of cotton.
You light the candle by holding the flame close to the wick. Most of the candle stays cool, but the top stays warm. The tip usually looks red when it burns.
The flame is smooth on the sides, but kind of jagged on the top. The wick stays white on the bottom, but the rest of it turns black.
The flame was about 2 centimeters tall and about 1 centimeter wide, and the candle got shorter as it burned.
And the candle material, I still think it's wax, but I won't say that, melts at the top and forms a pool of liquid.
When you blow on it, the flame changes shape, but when you blow hard, then it goes out. The liquid turns into solid, basically after you blow it, but then the top looks bowl-shaped.
The candle needs oxygen to burn.
Very good. I think we've heard enough. even though there are many more observations you could have made. But did you catch the 3 conclusions? Let's go back and hear them again.
The wick goes all the way through the center of the candle, and the wick is made of cotton.
Both of these are conclusions. Since the student has not cut the candle apart to see the wick in the middle, she is assuming that it goes from top to bottom. It might stop in the middle, and the wick might be made of a material that just looks and acts like cotton.
The candle needs oxygen to burn.
This statement is a judgment based on what the student already knows. He has not observed this directly with any of his senses.
Here's a chance for you to check your understanding of observations and conclusions. Number your paper from 1 to 8. As you hear each statement, write an O if you think the statement is an observation, and a C if you think it's a conclusion. Here goes. Number 1, this milk tastes sour. Number 2, the sour milk must be spoiled. Number 3, the temperature of the liquid is 33 degrees Celsius. Number 4, the wire must be made of copper because it is copper colored and conducts electricity. Number 5, it must be about to rain because the sky is getting dark. Number 6, when the powder was added to water, it fizzed. Number 7, the gas blown on the candle must be carbon dioxide because the flame went out. Number 8, lemon juice is an acid and tastes sour. All acids must taste sour. Okay, how do you think you did? Let's find out. Here are the correct answers. As you check your answers, remember, O stands for observation and C stands for conclusion. So, 1 is O, 2, C, 3, O, 4, C, 5, C, 6, O, 7, C, 8, C. If you got 7 or 8 correct, then give yourself a hand.
Now don't get me wrong, conclusions aren't bad. In fact, making conclusions is the last step of the scientific method. But we'll get to that later. Be sure not to get making conclusions confused with making observations. In fact, there's one more thing you need to know about observations. I hear bells. That's an observation. It must be time to take notes. Now that's a conclusion.
There are 2 types of observations, quantitative and qualitative. Quantitative observations include numbers. There's an easy way to remember this fact. The word quantity means amount, and because quantitative observations are measurements, they must include an amount, such as 25 grams or 2 centimeters. Qualitative observations do not include numbers. When you hear the slogan, "It's the quality of the time you spend, not the quantity," you know that quality of time does not depend on the amount of time.
Look at your observations of the candle now. Circle or highlight the quantitative ones and leave the qualitative observations alone. When you read a statement about the candle that's a conclusion rather than an observation, cross it out. It doesn't belong in your list of observations. Your local instructor will turn off the tape and give you enough time to do this and share your decisions with your class. Then, we'll return to this lesson. Welcome back. I hope your discussions were helpful. Let's listen to some of our students here as they make observations. Number your paper from 1 to 8 and label each statement you hear as qualitative or quantitative.
Since the letter Q starts each word, we'll use L for qualitative and N for quantitative. You don't have to write down the observations, just the L or N. Ready?
Number 1. The candle is white.
Number 2. It's shaped like a cylinder.
Number 3. This candle has a diameter of 2.1 centimeters.
Number 4. The candle material smells like wax.
Number 5. The candle material is soft enough to be scratched by a fingernail.
Number 6. The candle is lit by holding a flame close to the wick.
Number 7. The flame is about 2 centimeters tall and 1 centimeter wide.
Number 8. After the flame goes out, the liquid solidifies after 5 seconds.
Now check your answers.
Right now, you've learned an awful lot about the first step of the scientific method, making observations. Now, all those observations should lead you to some questions. Hillary, what question comes to mind about the burning candle?
Sometimes when you blow out the candle, you see some black soot. What is it and where does it come from?
I'd like to know what the candle is made of.
And why does a candle burn but other things don't?
Those are all good questions. Can you think of some others? I'll wait while your class talks. Local teachers, please pause the tape for your class discussion.
I hope you discovered a lot of things during your discussions. Speaking of discoveries, many scientific breakthroughs have been made as the result of questions based on observations. And that leads us to the second step of the scientific method.
After a scientist uses her senses and instruments to make qualitative and quantitative observations, she looks at her observations and tries to organize them in order to see patterns in relationships. This often leads to questions. The next step is to form a hypothesis to answer a question. A hypothesis is an educated guess based on what the scientist has observed and on his knowledge of science. It is in the form of a statement. A good hypothesis does 3 things for the scientist. It explains an observation. Remember, an observation is any information gathered using any of your 5 senses with the help of lab instruments. A good hypothesis can be tested. This testing can be performed in many ways in or outside of a laboratory setting. Finally, a good hypothesis will predict the outcome of an experiment. Hypotheses are often discarded when the outcome of an experiment testing the hypothesis is different from what it predicts. And that's okay, because the scientist has learned something from the test.
Okay, it's time for you to play junior scientist again. You've already made some good observations about the burning candle and have come up with some questions. I've picked 2 good questions, and I want you to come up with hypotheses to answer them.
Here are the questions. Write them down. Number 1, what is the purpose of the candle wick? And number 2, as the candle burns, it gets shorter. Where does the wax go? Now, remember that you're making an educated guess, so take a chance. It won't matter if you turn out to be right or wrong. Either way, you'll learn something. And that's the point after all. Your instructor will pause this videotape to give you time to answer them. Use a complete sentence to make a statement answering each. Don't start your statements with, I think. Scientists don't use first person in their writing. When you finish, share them with your class. Local instructors, you may now pause the tape.
I hope you came up with good hypotheses to answer all the questions. And I'll bet you're waiting for me to tell you the right answers. That's not going to happen right now. Let's get into our next step of the scientific method.
The third step of the scientific method is planning and performing experiments to test each hypothesis. An experiment is designed to test a hypothesis. The experiment involves variables. We'll talk about variables soon. And the experiment is performed under controlled conditions. You'll learn what that means in a moment.
Now, what are variables? Look at the word, variable. Variables are factors in an experiment that you are able to vary.
Any factor that can be changed in an experiment is a variable. Too many variables can ruin an experiment, so some variables are not allowed to change. A control is a variable that is deliberately held constant.
What do we mean by too many variables spoil the experiment?
Well, if too many things are changing, you can't tell which change affected the result.
That's right. So let's imagine an experiment so that we can control it. Let's say you wanted to find out which are smarter, solid color mice or spotted mice. And let's say your hypothesis is solid color mice are smarter. How do you test how smart a mouse is?
You just run them through the maze.
Okay, and what do you actually measure?
The amount of time it takes them to get to the cheese. So that's a variable too, right?
That's right, that is a variable, and that gives us two variables. That's all we can have. So everything else has to be controlled.
Now that sounds important. I'd write that down if I were you.
In a good experiment, only two variables are allowed to change. The scientist changes one variable. It's called the manipulated variable because it is changed by the scientist and does not depend on any other factors. For that reason, it is also called the independent variable. The responding variable changes as a result of the experiment. It depends on the other variable and is therefore called the dependent variable. Any other variables that might cause the responding variable to change must be controlled or kept constant. For this reason, these are called controls.
Okay, where were we?
Controls.
That's right, but let's back up a little bit. In our experiment, what was the manipulated variable?
The appearance of the mice, solid or spotted.
That's right, and what was the responding variable?
The time it took the mice to run the maze.
Good. Now, everything else has to be controlled. You can have no other variables or that would mess up your experiment. So what are some factors that you would control?
What about how hungry the mice are?
How much sleep they've had?
What about the sex of the mice?
Right, because females are smarter than males.
Yeah. What about the age or the health?
Do you see why we have to control so many variables? If you used a hungry spotted mouse and a solid colored mouse that had just had lunch, you wouldn't know which factor affected the results. So the results wouldn't actually test the experiment. Got it? Good. Now let's test the hypothesis most students formulate to answer our first question about the burning candle. The question was, what is the purpose of the candle's wick? Most students think that the wick is the part of the candle that burns to produce the flame. That makes a good hypothesis. Let's test it.
Okay, we want to design an experiment to test your hypothesis that it's the wick that burns to make the flame on a candle. Now, what else could interfere with our experiment? What else could burn besides the wick?
Well, there's only the wick and the wax, so it has to be one of them.
Okay, so how will we design a controlled experiment just to test that hypothesis?
And we could try to burn the wick without the wax.
Okay, and any candle maker will tell you that wick is made of a cotton twine like this. So what do you think the purpose of the wax is?
To hold up the wick.
All right, so we're going to let you use tongs, Christy, to hold up the wick and put your goggles on. And Erica, if you'll light a match and light it.
I guess it's burning, but it's not the same as regular candles.
Well, so you're not quite ready to give up your hypothesis, and that's good. Good scientists don't give up that easily. So let's try another test. This time, let's use the actual candle so you'll be convinced that we're using the real wick. If you will light the candle. And Eric, I want you to take this piece of aluminum foil that has a slit and just separate the wick from the rest of the candle. That's all right, and pinch it off. And wait, and what do you see?
Okay, the flame went out, so I'm convinced. The candle does need the wax to burn.
Okay, and so you're ready to say that you've disproved your hypothesis.
Right.
And that's fine. A no answer is as good as a yes, because we've learned something either way. So let's go on to the second question. The second question was, what happens to the wax as the candle gets shorter?
Well, I thought that the wax would melt and run down the side of the candle.
Okay, and how would you test that hypothesis?
Well, if we all know that the wax is going to burn, then why do we need to?
Well, we don't have to, but what if you wanted to humor me? What kind of experiment could you design?
I'd weigh the candle and then let it burn and then weigh it again.
Okay, and you would find that the candle actually loses weight. So what do you think happens to the wax?
It probably turns into a gas and floats off.
Okay, and that does happen, but what we find is that the wax turns into a gas or a vapor even before it burns. And what we find is that when you light the candle, the wick burns, and the wax at the top of the candle forms a pool of liquid. The very base of the wick will be wet. And let me give you an example. What happens when you take a paper towel and put the corner of it in some water?
It goes up the paper.
Okay, and that's sometimes called a wicking action, which is exactly what a wick does. The liquid wax climbs up the wick, vaporizes, and it's the vapor that burns.
Now we come to the last step of the scientific method, which is making a conclusion. You saw our students discussing the results of their experiments and making conclusions. Scientists make their conclusions after a great deal of experimentation. Sometimes they go back and change hypotheses and then test again. When the results of the experiments show that the predictions of the hypotheses are successful, scientists go a step further and publish their results and conclusions so that other scientists can use the information. The scientific method is not effective if no one communicates the results.
Chemistry by candlelight is kind of romantic, isn't it? I think we've learned a great deal during our first lesson. Now you'll get a chance to show what you've learned in our final segment, the chemistry quiz. Don't write the questions, just the letter of your answer. When this tape ends, your teacher will go over the correct answers with you. Here goes.
You have nothing to fear. You're about to experience
Dun, dun, dun.
the chemistry quiz.
Chemistry is the study of A. Candles, B. Properties, C. Reactions, or D. Matter.
Which of these is a qualitative observation? A. The candle is 3 centimeters long. B. The wick of the burning candle is curled at the top. Or C. The wax contains carbon and hydrogen.
Number 3. An educated guess which explains observations is called A. A law, B. An experiment, C. A hypothesis, D. A variable.
In an experiment, the variable which is deliberately changed by the scientist is called A. The controlled variable, B. The manipulated variable, C. The responding variable.
True or false? When a hypothesis is tested and shown to be incorrect, the experiment is a failure. A. True. B. False.
Thanks to my students for bringing you questions to ponder and discuss. See you next time. And that's a conclusion.